class, right? And we haven't gotten to a lab on this yet, but Purva discussed, list comprehensions, and we obviously went through, right, this bike sharing lab, and technical communication, right? So that's something, again, like you just want to practice and emphasize, and we will emphasize it throughout the course. We'll probably even build it into quizzes, so it'll be something you're evaluated on, and you'll be evaluated on it because, frankly, like in your career, you'll be evaluated on whether it's explicit or not. And I personally find it kind of like a low-hanging fruit too, in terms of just career progression and also value added. Like if it's something that you pay attention to, it can provide really just a lot of value. And especially the further you progress in your career, as you might imagine, the more important it becomes, whether you're mentoring others or just collaborating with other stakeholders. So we talked about that. List comprehensions we'll get into. We'll do a lab on that. For right now, I did want to pay special attention to, what I'm calling like coercion methods. And what I mean by this is, going from one data type to another, all right? Because I think that all of you are familiar with these more or less, but they're just very important they're probably like of the different operations, in my opinion, they're some of the more important ones because in data engineering, in engineering in general, you're always trying to think of what is the right data type, right? And transform your data into that ideal data type. So one thing just to pay attention to is, how data types are similar to one another. For example, a string, as you might kind of imagine, is pretty similar to a list, right? If a list is an ordered sequence of elements, right, then a string is also ordered, right? It's an ordered sequence of characters. So just like we can, slice through a list, we can also slice through a string, right? And we can also select elements from a string. We can, iterate for char in hello, print each character or something like that, right? We can iterate through the characters of a string. So what you might imagine if, say, we wanted to coerce a string into a list, how would that actually, what would the transformation look like? Well, one, you can use the constructor. So each one of the data types has its own constructor, okay? And for normally it's just the name of the data type. So for a list, it's list, right? And you can do list, and now we are taking the string as an argument, right? And we are producing a new data structure or a new instance of a list, okay? And you can see that each character, just like the character similar to the element, well, now it's literal, right? The character is each element in the list, okay? How do you go back? I don't think this will work, right? It didn't really work. I mean, it doesn't look great, right? It's giving us the square brackets or something. We know how to go back, right? We have to do the dot join. So it's a little, I always find the dot join method just a little weird, but that's how you go back to it, all right? Cool. Okay, so, we saw how we can go from a string to a list. Obviously, like sets are very similar. You can think of, if I want to have a list of names, or greetings, I guess. Let's do names. Bob, Sam, Fred, Bob again, right? And then I want to get the unique list of names, right? Well, then it's set and then coerce that back to a list. So you can see, right, here's our second example of a constructor, right? That is used to coerce from one data type to another. The reason why this is called a constructor, by the way, is because it literally constructs a new instance of that type of data. So this is what I mean by that. If you don't provide an argument to this, it builds a blank list. If you don't provide an argument to set, it builds a blank set object, right? Or I should say an empty list and an empty set object, all right? Same thing, I believe, probably with string. It's not like I do this often, but this is producing an empty string. Okay, so these are why each data type has a constructor. For int, my guess is you have to actually provide a number, right? But same thing, we can coerce a float to an integer with a constructor. Okay, let's see if we can do it with a string. Will this work? I wonder. That doesn't work. but that does. Okay, so for the string, it's a little rough, right? We'd have to probably first coerce this to a float, then coerce it, then coerce that float to an integer, right? And a float is just a number with a decimal point, as I think a lot of you know. All right, so yeah, so lots of times what we do, what we prefer to do is change things into lists. Like we do that all the time. The fact that lists are ordered is quite nice. Makes it easy to coerce them or to like select from them. So let's talk about like how we take a dictionary and move it to a list. So that would be, let's do this. Name Fred, or yeah, Fred is fine. Hometown is New York. All right, and this is our person. Okay, so how do we turn this into a list? I mean, you could, again, try to use a constructor, but it doesn't give us exactly what we want, right? It gives us the keys, okay? So probably what's a little bit better is to use the dot items method, okay? So here you can see what's occurring is that it takes this list and it moves it into a collection of key value pairs, right? So it's a nested list, essentially. More like, we can be a little bit more specific than that, but it looks like a nested list where this list has two elements in it. Each element is a key value pair, or is a tuple really, where the first element in the tuple is a key, the second is a value, then key value over here again. An issue with this is it says dict items, right? So it's not actually a list, right? If you do a type to check it, it tells you this is a type of dict items. And it's like, well, what's the difference? The difference is this is harder to work with. For example, if I want to select the first element from here, I cannot do that, okay? And it says dict items object is not subscriptable, right? This is the subscript. That's another kind of fancy word for this, right? Like selecting this one component of it. Same thing, we can't slice it, right? So this thing's actually a little annoying to work with, but what we can do is just turn it into a list, and now, you know, if we want to slice it, now we can do that, okay? So in order to turn a dictionary into a list, right, we start with our dictionary, then you do dot items, okay? And now we can turn that into a list. And this can be useful, you know, for various things. We'll find uses for this, but this can be pretty useful. Like, for example, if say you just want the first like 3 key value pairs in a dictionary or something like that, right? It can be useful. All right, and then the other thing. So basically, what we're learning, you know, what's a good way to organize this stuff in your brain too, is to think of like the inverse. You know, so we saw how to go from a dictionary to a list of tuples. Can we go the other way? You know, can we go from a list of tuples into a dictionary? And the answer is you can. All right. So this is actually very useful to know. Why? Because oftentimes what you'll have, I have it down here. Say we have a set of keys, and then we have a set of like values. All right. Now this separately won't give you what you want. Like let's say we have keys and then Sam values. If we like try to, it doesn't even work. What if we package them together? Let's take a look at this. This is not exactly right either. Do you see this? Right? This is what we had previously. This is what we had previously. Right? What we had previously was key value, comma, key value. Here we have key, value, value. So if we do this, this is off as well. All right? Name, hometown, right? Key, value, value. What we want to do instead is take the lists. Let's take a look at this. So we have keys. That's name, hometown. We have values. That's Sam, NYC. And actually we want to produce this, name Fred or name Sam, hometown, NYC. So we do that with a zip. All right, and I'm just going to do, if you just do zip, it's opaque, right? But we can force that to a list. So this is what we want, right? We want to take name and pair it with, take the key, pair it with the value, take the hometown and pair it with the value. So what zip does is it pairs together your lists by each corresponding index, right? It matches the indices of each corresponding element in the list. All right. Now from there, we can do dict, and we're good. So this is a useful operation. Just to bring it home, this is pretty typical, right? Where we have a list of values, or for example, maybe we can just produce a list of values, and we say, okay, for each set of values here, this kind of represents the attributes of an individual. We want to produce a dictionary, right? We want to add labels to these. So what we can do is we can take these keys and we can basically say, okay, for customer attribute in the list in this whole set of customer attributes, what I want to do is take the keys, zip them with the with each pair, right, one by one of customer attributes. And then let's do again, we don't have to do this, but it makes it a little bit more visible for teaching purposes. I'll just print it out for now. So you can see this is pairing them up, right? It's going through Sam NYC and pairing it with, name and hometown. And then it goes to Lisa Chicago and pairs that again with name and hometown. So these are constant, right? The keys are constant. We only need to declare them once. But the values, we're iterating through each set of values. And then, of course, what we can do is, actually, let's just directly turn this into a dictionary. And, call this customers. Do customers.append. And I broke it. I think I have an extra parentheses. All right. So for each, set of attributes in my customer attributes, we go through them one by one, this pair, and then we pair it together with my keys, and then convert it to a dictionary, and then append it to the list. All right. And then of course, we can do. So this is pretty useful, right? By the way, all right, I'll show you that we can do this with list comprehension, and then I'll raise a point. For customer attribute, right, in customer attributes, so I'm always just naturally writing the for loop first, like Apurva mentioned, and then we can just take this part, right? Zip together the keys, let's actually move them down, with the values, and then produce a dictionary. All right, so it's pretty useful, right? And just like a single line that we're able to do this. Notice, by the way, when in terms of my naming, I'm using I'm reserving customers for the full dictionary. This to me is almost, I don't know if everyone does this, but this is to me complete. Basically, when I have it's similar to what we'll see as an object, right? Is a dictionary is probably closest in line. So this is kind of complete, whereas other ones I'm kind of prefacing and saying, okay, these are maybe just the characteristics of each customer. These are the keys or the descriptors of each of those characteristics. This is them, together. All right. Cool. Any questions? We do have maybe one more thing to talk about, but so far, we talked about going from strings to lists and how they're similar. We talked about obviously sets and lists. Again, we talked about these constructors as ways that we're coercing data from one form to the other often. And then dictionary, right? Dictionaries maybe it's just a little bit more complicated, where you do call the dot items and then, convert it to a list if you need to. Does it feel all right? Okay. Let's talk about one more thing, which is unpacking our data. So this is the movies data set. So we have a set of, let's say we have a list of titles, and then we have a list of genres. Okay, and then again, we want to pair them together. How do we do that? Well, we zip them, the titles and the genres, and that produces a zip object. Now we can unpack these, right? So let's iterate through them. So we'll just say for a movie in this zip object, right? And remember, you'll think about this zip object as this paired tuple. So let's say, for each kind of movie pair or whatever in this whole list of pairs. For movie, I'll just call it pair, even though that's weak, in this list of pairs. What will we do? Let's just print it or something like that. Print the movie pair for now. Let's just do the first 5. All right, so you can see this movie pair represents each tuple in the list. All right, pretty standard stuff. Now, what we can do, however, is unpack this, meaning unpack each element in the list into their like constituent parts, right? Into element 1 and element 2. So the way you do that is we'll call this for title, comma, genre. And now I'll print out title, genre. In fact, I'll just say title is that, and then the genre is that. Okay? So now title, right, for each one of these, let me make this a little more visual. Okay, so for each one of these things, okay, so for each one of these, we go through them and we separate them into their, constituent parts. So this gets separated into title, genre, then we go to the next one, and then this one gets separated into title, genre, right? And then we go to the third one, title, genre. These have to match, you know what I mean? Like we have 2 elements here. If you put 3 here, title, genre, year, you kind of make a mistake here. It says not enough values to unpack, expected 3 values to unpack, but only got 2. Does that make sense? Right? Expected 3, but then when I looked at it, it only got 2. So this can be useful, for instance, what if you just want, the title from each one? You can kind of you could do that kind of easily. You could just get the title and add it to a list or something like that. So this is something useful to know, or just just want to separate it out. Another thing that you can do that's similar to this is, let's say let's take Oliver Twist. Let's say you just have a tuple, right? And this is kind of my first movie, right? Here's my first movie. It's Oliver Twist and crime. If you want to, on the fly, you can do title, comma, genre, or first title, comma, first genre equals first movie, right? And that will separate, here's first title, here's first genre, okay? So we're relying on the fact that we know this is a tuple, or not even a tuple, this could be a list as well, but that this has 2 elements, and then we're unpacking this. Okay, so you might see this as well. You don't have, it's a little fancy. Is there any, let's take a look at this question. Is there any use case or scenario where we need to directly access elements of zip tuples without coercing them to a list? Okay, if yes, how do we access them using an iterator? So I think I get the question. You do not have to, let's say we have these titles and genres, and we zip them. Zip together titles, genres, right? And now you do not have to do this. I'll do it this way first, and then I'll show you that this is extra. Let's just print title, comma, genre. Okay, so we're printing this out, Oliver Twist crime, whatever, but I'm just really doing this to be visual with it. Probably most developers will not add this line here, okay? So if I do this, same exact result. It's similar to, I think, what Alan was asking maybe yesterday about the list around the reversed. You don't have to do this, the list thing. Honestly, I'm doing it really for teaching purposes, because it's just more visual that way. Okay, so this is one thing, right? We can, zip object is not, look at that, it's not subscriptable. Probably because it's not fully generated, but that's okay. So let's just convert this real fast. Okay, next thing. A case that this is done pretty often, actually, is with dictionaries. I'll tell you where it's done quite often. Let's do this. Okay, it can be pretty common that you'll have a dictionary and it'll have lots of attributes in it that you actually do not need. All right. So let's this will be Oliver Twist, or let's just call it like this is just a movie. All right. So what's pretty common is, again, like you may, have all these attributes, and this is like 5, it's not, or 6, it's not a big deal, but maybe there's like 30, right? And you only need 5 of them. So what you may do is do something like, here we have movie.items, right? And now, just like we can iterate, this is, again, basically a list of tuples, right? So that means we can iterate through each of these. Okay, so again, let's just do that again. So we have the movie, then we call movie.items. We don't need list here either. And for each tuple here, we'll unpack it into its constituent parts, this time it's key value, right? And print out key, comma, value, right? Then go to the next one, key, comma, value. Why is this useful, okay? It's useful because really what you do oftentimes is you say, let's go through each one of these key value pairs. If the key is in, right, a specified list, let's say title, comma, genre, then I want to add it to the list. Okay, I broke it. I need an extra parentheses here. Okay. So we start off with a large dictionary, right? 7 attributes, but it could be 30. Then of them, you specify these are the attributes we want to hold on to. You add them for each key value pair. Go through each one of these pairs. For each one, check the key. Is the key in this selected list, right? In the list that I want. If it is, store both the key and the value as a tuple, and then of course we can convert it. Let's do that one more time. We have this dictionary, it has too much stuff in it, right? So then what do? We say, okay, of these things, let's say I just want to let's take a look at these keys. Which ones am I interested in? We're interested in title. And normally I'll literally just copy and paste it. Let's say we want like title and year. I'm going to call these like my attributes that I want. Title, comma, year. Cool. Now what do I want to do? Take the movie for K, comma, V. All right. For K, comma, V, in this list of tuples, in movie.items, right? If the key is in the specified attributes I want, right? Is in the attributes. If it's either title or year, then add it to the list, right? And do selected attributes dot append that tuple of both key and value, right? Because ultimately I'm going to turn this back into a dictionary. Okay. So you see that? Go through each one of these key value pairs. If we find the matching key is in this specified list, add it, hold on to it, right? And hold on to both the key and the value. Then we have the collection we want. We're back to a list of tuples. Convert it into a dictionary. Okay. Let me see, we got a couple questions. Would it be more efficient to cast the tuple to a dict in the loop? I think I get what you're saying. Right
there in that line.
Which line? Here?
Yeah, if you're gonna append a dictionary item to your list, is what I'm. Like, can you just cast that tuple to a dictionary?
I mean, normally what you'll see is what's called dictionary comprehension. I mean, you could do it different ways. Like, you could start, so maybe this is like step 1. So we could say, like, here's my, resulting, movie or whatever we'll call it, selected movie, right? So this is now a dictionary. What you could do is say selected movie, right? And then square bracket key equals the value, right? So just, take, if the key is in this list of attributes, go through each one of these key value pairs. If the key is in this list of attributes, take the dictionary, add a new key value pair, right, of this K comma V. And that way we don't...
Won't that be, won't you get a lot of duplicate keys that way?
I don't think so. So let's call this selected movie. Because we're going through each key value pair once, right? So we're going through this, and then we're saying if the key is one of these attributes, add this key value pair.
Right, sorry.
You see what I mean?
This is for just one movie. I guess I was thinking about the whole list of movies.
That works as well. So let's just make sure, so for each one of these, now we add a key value pair, and we wind up with a selected movie. If you want to go through each of the movies, like we have here, all these movies. So let's take a look. So we have all these movies, right? We can say, for movie in movies, for each movie, right? For each movie, each of these guys, in the list, create a new dictionary, right? Because we're going to need to, probably. We don't want to change the original. So create a new dictionary, go through each of the key value pairs of that dictionary. If the key is one of the selected ones, one of the special ones, update this dictionary, and then you can, selected movies, add it to the list. You would probably do that here. Selected movies dot append selected movie. This is a nested loop now, so it's not so much fun. But you have right. There are other ways to do this. The lesson actually but sometimes this is the best way. So this worked first of all, but then let's just make sure we get what's going on here. We started with the whole list of dictionaries, right? We go through each one of them, right? Each of the original dictionaries. For each original dictionary, declare a new one, right? Like this is my placeholder. Go through every key value pair in the first dictionary. If the key is one of the special ones, add the key value pair. After we go through each of the key value pairs, we're done with that dictionary, add it to the list, right? Then go to the next one. Create a set, a blank one, go through each of the key value pairs in the second movie, in the original. If the key is one of the specified, add that key value pair to the dictionary and then move on, right? Then go to create a new one. So the reading shows you there's a different way to do this as well. Sometimes this is a little, and we'll see both, and I think you might get a feel for when this is okay. Just know this is confusing, right? Like this is confusing. Like I have to focus a bit too when I'm doing this, because why are nested loops annoying? Because think of all the variables you need in your head to keep track of. Movies, that's 2. Selected movies, that's 3. Key value, that's 4 or 5, right? Attributes, that's 6. Like that's too much, right? Or it's just tricky to do that. Generally, we prefer to not have that many variables in our head, but for right now, it seems like before at least we learn about functions, it seems like we need to. All right. Cool. So basically what we learned here was like unpacking, the fact that while we're iterating through a nested data structure, right, a list of tuples, okay, we can unpack them, right, for K comma V in this, right? If we don't unpack it, this will be a key value, then it just will print the original tuple, right? If we do unpack it by putting a comma in between, then now it splits them up, splits that tuple, breaks it apart. I always think of like a peanut, like splitting apart each peanut into the 2 nuts. That's what I think of. But anyway, that's what this does. All right. Anything else? I think that's pretty good. This may take a second to get the hang of, just a warning. All right. It's okay if it takes even like more than a couple days just to get used to this. That's fine. Questions about... Oh, I stopped my... Sorry about that, guys. I turned off the wrong thing with them. But, like, when I entered being a software developer, this is what you really see is, like, the more senior developers, they don't necessarily, like, think any faster than you do. They just have techniques for breaking the problems down more. So the typical way is simply when you have a collection, just work with a single item in the collection, right? Just work with a single element in the collection. So what we want to do is, we start with this list of dictionaries, and we want to get it to a string that says something like name is Sam and hometown is NYC, comma, name is Lisa and hometown is Chicago. Okay. So really the pattern, it's okay, not to see this, but is actually something like K, right? I'll do it this way. K is value, right? So it's like key is value and key is value, right? So it's like this key value pair and then that key value pair. Okay? So and we want to do that for each element. So let's just start with a single dictionary. And we'll call this customer. And then we create the customer. And now we want to do, K, basically it's almost like K comma V. K comma V. Except that it's K is V, right? So customer.items, and then for K comma V in customer.items, right? So this is our list of tuples, right? So we go from our list of tuples back to unpacking each one, and then we'll print it. So print K comma V. All right. So name, Sam, hometown, NYC. Now it's starting to sound easy already, right? So instead, let's just do is, and we need the commas, don't we? I don't know what I did wrong. Okay, name is Sam, hometown is NYC. All right, that's pretty good. So basically, we're going through each one of these key value pairs, printing them out. Instead of doing that, let's call this like my phrases or something like that. And instead of printing it, we'll do phrases dot append the we'll call this my phrase. And this is, you can kind of add this stuff, I suppose, but I find that a little harder to do, So it's like for each one of these, we'll add the phrase. The reason why I find it harder is I always forget the spaces, right? Name is Sam, hometown is NYC. So we'll just, I think something like that. Name is Sam, hometown is NYC. And now this is pretty easy. Like what do we want to do? We want to turn that into the word and. So we want to combine these two things with the word and, right? So what do? We take the list of phrases and we'll do join it. On the word and. Something like that. Name is Sam and hometown is NYC. So now the game is easy, right? Because we did it for one and we just have to hopefully loop through it for customer in customers. Take these phrases, take the key value pairs, and maybe this is a bad name, and join it together, and maybe what I'll call this is my sentence, right? My sentence is this join together thing. And now for each customer in the list of customers, did I spell sentence right? I don't think so. It looks better. I will do sentences dot append. No, I want to do that here. For each customer in the list of customers, do sentences dot append the sentence. And I know I have to declare that variable. All right? So let's think about it. For each customer in the list of customers, create a list for the phrases. Okay? Then go through each. Now we have our first customer. We're going to go through the list of tuples, create this string. Name is Sam. Add it to the list. When we're done with the list of tuples, right, we have these phrases. Then we finally join them together, add it to the list. Then we go to the next customer, right? Construct the phrases, compile the phrases into a sentence, add it to the list. Something like that. Beautiful. What did I do wrong? Oh, maybe it's just not displaying? I don't know. Or maybe I did it wrong.
I think you need to put dot and sentence.
I need to say that one more time.
Your sentences dot append sentences.
Oh, that's fun. Thank you. Name is Sam and hometown is NYC. Name is Lisa and hometown is Chicago. Name is... So you guys saw what I was doing? I was appending sentences into itself. That sounds weird. Let's not do that. So instead, right, create each sentence and then append it to the list of sentences. Next thing, I don't think we talked about this yet. How to make this part easier, which is, you can create new strings by just adding, doing the plus sign, but it's a lot easier. And like the preferred way to do this is with an F string. So the way it works is, let's say you have a name is Sam and the hometown is NYC, right? If you just, I think it works with either single quotes or double quotes. If you do, you'll start with the letter F beforehand, okay? Then you do the quotation mark. Now if you just do like hello world, nothing happens. But now you can have a variable inside there as long as you do the curly braces. Okay? So the name is name. All right? Here it's literal, right? It is just the word name. Whereas here you can see it's looking to the variable name, right? And hometown is hometown. Okay? So it's easier, I think, actually. So you just put the letter F before the quotation mark, and now, like, this is called interpolating. It interpolates, right? It replaces the variable name with the actual variable. And you can put anything in here. Like, this just evaluates Python. Okay? So what we probably should do just to make this easier is change the phrase, right? So instead of this, we'll do phrase equals F string with K is, oopsies, sorry about that. K is value. Take the phrase, append it, still join together with and. Hopefully that works. Okay. So, right, I don't like nested loops, but we are using them here. One way to make it a little easier for you, again, is just start with a single customer. Just start with one item in the dictionary. It's fine to do, like, it's preferred to do that, right? It feels like you're slowing down, but you're actually making things clearer for your partner as well. You're making it easier to follow the logic both for you and your partner if you just take it one at a time and then move back. And it's also less likely to produce bugs. So that's one thing, right? Is do it for one, then do it for all. The other thing is just look at how I'm naming the variables, right? I saw a lot of this, string lists or something like that, or list strings. What's hard about this is it's hard to know what we're referring to, right? We only have like 5 data types, and basically we're working with like 3 of them all the time, strings, lists, or dictionaries. So when you do something like this, it's really hard, at least for me and my brain, to like immediately know, like my brain's basically going, okay, what is this again? Like, what does this represent when I see it in my code? So it's a lot easier if you instead use a descriptive word, okay? So all you have to do is, for anything that's a list, it's always plural, For anything that's a dictionary or a string, it represents one item, and so it's singular. And now you can see even here, I'm like trying to use words that tell, that are really descriptive, right? A phrase, compose it, right, is like kind of like the atomic element of a sentence, right? A sentence has many phrases, and in each phrase, right, I'm using the customer key value pairs. Even like this is, I guess, the only thing that's generic and maybe okay, right? Because it just is key value, and those keys and values change each time, right? Like it's name one case and its hometown the other. So here it's okay, but otherwise we're trying to be pretty descriptive throughout. Okay, and this is right. There's this famous thing. There are only two hard things. There we go. There are only two hard things in computer science: cache invalidation and naming things. All right. So naming things is like a known challenge, but you want to like we're giving you some guidelines for doing it, right? When it's singular, keep it singular, right? And then when it's a plural, when it's a list, really have it plural, right? When it's a dictionary, generally represents one thing. String as well, right? Phrases, right? This is a string. This is a list. Sentence. This is a string. This is a list, right? This is a dictionary. This is a list of dictionaries. So that it will save a lot of your brain space to actually focus on the logic of code instead of remembering what every variable is. And also, not only that, but when you go back like a month or a year later, this is way more easy. This is a lot easier to follow than using the data types words. Cool. Then for the lab, what's fun about it is I did one of the problems wrong early on in the list comprehension lab. So what I did incorrectly is forgot the apostrophes in associates, bachelors, and masters. So there's an apostrophe. But when I solved it here, I forgot that. And because of that, I only captured 75, when really there's, I think, like 384. So these values are off. I apologize. I think that I solved it properly just now. So I'll try to push that. But it has the answer, so when you look at the answers, you can see, I'll try to update that so you can see that. But I think in general, it feels like you have the hang of list comprehensions, which is nice. And then there's the next stuff, right? So then the next stuff to do is zipping and unpacking lab, and then, have the solution there. And then if you finish this, which I think you all might be pretty close, I'll deploy this as well. And this will probably take us towards the end. I'm not sure if you'll finish this tonight. This might go into tomorrow. Okay, so I don't know. We talked about naming things. We talked about, I don't know, starting with one and then moving to all of them. Do try to use that. Any questions about this stuff before I put you into breakout rooms? Let me just check the chat real fast. I think we're good. Okay, cool. All right. Let me open up the breakout.